Hello friends, I hope you are safe and strong at your home. I am Bhagyesh Thakkar, maths teacher and principal of Vidyut Board Vidyalaya English Medium. Today I am going to start chapter number 2, standard 10. The name of the chapter is Polynomials. First of all, we will discuss some concept of this chapter, that is polynomial, and then directly we will start some example of this chapter. There are only 11 concepts in this chapter. We can say the 11 points, they are very important to understand this chapter. So let us start to explain this 11 point. The first point, that is, what is polynomial? Any algebraic expression in which all the variables involved are having non-negative integer and exponent. Non-negative means 0 or positive, an exponent. So the polynomial means any algebraic expression in which all the variables involved are having non-negative integer exponent. Now, second article of this chapter is degree of this polynomial. The highest power of x of the polynomial px is known as degree of polynomial. Let me take one example. For example, px is equal to x square plus x plus 5. You know the polynomial is denoted by px if x is variable. You can also write py if y is variable. Here x is variable, and that's why the name of the polynomial is px. The polynomial is x square plus x plus 5. You know the degree of this x is 2. Here degree of this x is 1, and here only constant 5. So you can write 5x raised to 0, means the degree of this term is 0. So the highest power of x in this polynomial is 2, and that's why 2 is known as degree of this polynomial. Let me start the third concept of this chapter, and that is linear polynomial. Why it is known as linear polynomial? Because the degree of the polynomial is 1, and that's why it is known as linear polynomial. So a polynomial of degree 1 is known as linear polynomial. Let me give an example. For example, px is equal to x plus 5. If you take y variable, then py is equal to 5 plus y. You can also give an example, px is equal to 39x plus 2. All these three examples are examples of a linear polynomial. Now the fourth concept of this chapter is quadratic polynomial. Quadratic, quadra means 2, and that's why a polynomial of degree 2 is known as quadratic polynomial. Here we have taken one example. Px is equal to x square plus x plus 5. Here the highest degree is 2, and that's why it is a quadratic polynomial. Well, let me start the fifth concept of this chapter, that is cubic polynomial. So a polynomial of degree 3 is known as cubic polynomial. Let me take one example to you. For example, px is equal to x cube plus 9x plus 2. So here the degree of this polynomial is 3, and that's why it is known as cubic polynomial. Now, the sixth concept of this chapter, a very important concept for your exam point of view, and that is zeros of a polynomial. We will solve many examples to find out the zero of a polynomial. So, let us start. What is zero of a polynomial? Zeros of a polynomial. If k is a real number, you know what is real number? If k is a real number and pk is equal to 0, then k is known as zero of the polynomial px. Means if you place the value k in a polynomial, if it is 0, then we can say that it is a zero of a polynomial. Again, let me explain this definition. If k is a real number and if you find the value of pk, means value of polynomial at x is equal to k. If it is 0, then we can say that k is a zero of this polynomial px. Well, so here we have discussed first one, polynomial, then second article is degree of polynomial, third article is linear polynomial, fourth article is quadratic polynomial, fifth one is cubic polynomial, and sixth one is how to find out zeros of a polynomial. Now let me start seventh concept of this chapter. The seventh concept is graph of linear polynomial. The general formula of a linear polynomial is px is equal to ax plus b. Here the name of the variable is x and a is known as coefficient of x while small b is known as constant coefficient. If we draw the graph of a linear polynomial, as power of x is 1, degree of x is 1, the type of graph is a straight line. Either it intersects both the axes, or sometimes it is parallel to x-axis, or sometimes the graph is parallel to y-axis. You know, the intersection of graph with x-axis is also known as zero of the polynomial. Today we have discussed what is zero. If pk is equal to 0, then k is known as zero of the polynomial. Here, the graph intersects x-axis at one point, and that's why it has 1, 0. Here, the graph do not intersect x-axis, though it intersects y-axis. But it does not intersect x-axis, and this graph has no 0. While here the graph intersects x-axis at one point, and that's why this graph has 1, 0. So friends, now you know how to find out the graph of a linear polynomial. If you draw the graph, it is a straight line. It intersects the x-axis either at one point or no point. If it intersects at one point, it has 1, 0. If it do not intersect the x-axis, then it has no 0. Now let me start another very important article of this chapter. The article number 8, that is graph of quadratic polynomial. You know what is quadratic polynomial? A polynomial having degree 2 is known as quadratic polynomial. So the general formula of quadratic polynomial is ax square plus bx plus c, where a is known as coefficient of x square, b is known as coefficient of x, and c is known as constant coefficient. If we draw the graph of this quadratic polynomial, you will get a parabola. it is either upward parabola or sometime you get downward parabola. Again, ax square plus bx plus c is general formula of quadratic polynomial. As degree is 2, if you draw the graph of this polynomial, you get parabola. It is either upward parabola or downward parabola. Now, question is how to identify whether it is upward parabola or downward parabola. If the coefficient of x square means a is negative, then it is downward parabola. If the coefficient of x square, that is a, is positive, then it is known as upward parabola. Sometimes they ask this question in your examination. If it is upward parabola, then the coefficient of x square is always positive. If it is downward parabola, then the coefficient of x square is always negative. Well, so if you draw the graph of a quadratic polynomial, you will find there are 6 types of varieties of this graph. First one, it is upward parabola and the coefficient of x square is positive. And this graph do not intersect x-axis. Though it intersect y-axis, it do not intersect x-axis, and that's why it has no zero. If you observe this graph, it is also parabola, upward parabola, and that's why the coefficient of x square, that is a, is positive, and it intersect axis at one point, and that's why it has only one zero. Let us observe this graph. Here this graph intersect the x-axis at 2 points, and that's why it has 2 zeros. If you observe the graph, it is upward parabola, means it intersect x-axis at 2 points, upward parabola, and that's why the coefficient of x square is positive. Let us discuss these two concepts in another graph. This graph, downward parabola, so coefficient is negative, do not intersect the x-axis, and that's why it has no zero. Here in this graph, downward parabola, so the coefficient of x square is negative, and it intersects the x-axis at one point, and that's why it has 1 0. While in the third graph, it is downward parabola, and the coefficient of x square is negative. It intersects the x-axis at 2 points, and that's why it has 2 zeros. So the first one is graph of linear polynomial. Ax plus b is a general formula. The graph is straight line, and it intersects maximum 1 point, means it intersects x-axis at either 1 point or 0 point. The graph of the quadratic polynomial ax square plus bx plus c is general formula. The graph is parabola. It is either upward parabola or downward parabola. If the coefficient of x square, that is a, is positive, then it is upward parabola. If it is negative, then it is downward parabola. And you can conclude one thing, that is the quadratic polynomial has maximum 2 zeros, means either it has 2 0, 1 0, or no zero. If it intersects x-axis at 2 points, it has 2 0. Intersect x-axis at 1 point, it has 1 0. It do not intersect x-axis at any point, then it has no zero. Now let me start 9th concept of this chapter, that is the graph of a polynomial of degree n. We have discussed graph of linear polynomial, graph of quadratic polynomial, that is polynomial with degree 2. Now the graph of a polynomial of degree n. N means natural number. So you can take 3, 4, 5, etc. So the polynomial, let me take a polynomial with degree 3. It is known as cubic polynomial. So px is equal to ax cube plus bx square plus cx plus d is general formula of cubic polynomial, as the degree of this polynomial is 3. Here there are 4 coefficients. The coefficient of x cube is a, the coefficient of x square is b, the coefficient of x is c, and the constant coefficient is d. You know, it is known as what? Cubic polynomial. So if you observe the graph of cubic polynomial, it is always a curve. It is always a curve. And the degree is 3, and that's why the conclusion is it has maximum 3 zeros. Means it has 3 zeros, 2 zeros, 1 zero, or no zeros. Well, let me explain this graph. You know, here graph is curve and it intersect x-axis at one point, and that's why it has only 1 zeros. Now here the graph is also a curve, and that's why it is a graph of cubic polynomial, and it intersect x-axis at 2 points, and that's why it has 2 zeros. Let me explain the third graph. Here it is a curve, and that's why it is a graph of cubic polynomial. And you can see this graph intersect x-axis at 3 points, number 1, number 2, number 3, and that's why it has 3 zeros. So if it is cubic polynomial, the graph intersect the x-axis at maximum 3 points. Again, let me explain this thing. Maximum 3 points means the graph intersect x-axis as either 3, 2, 1 or 0 point or no point. Well, so the concept is the graph of a polynomial of degree n. Suppose the degree of this polynomial is 4. So the nature of the graph is curve, and the graph intersect x-axis as either 4 point, 3 point, 2 point, 1 point or no point. Let me take one example to you. Fourth one. You know, here the graph is curve, and that's why it is a polynomial of degree n. Here the graph intersect the x-axis at 1, 2, 3 and 4 point, means this is a polynomial having degree 4 and it has 4 zeros because the graph intersect the x-axis at 4 points. So the point number 9, that is the graph of a polynomial of degree n. N means you can take 3 and 4. It is cubic polynomial, means it has 3 zeros, maximum 3 zeros. If it is polynomial of degree 4, then it has maximum 4 zeros. Well, now let me start another article that is very important article of this chapter, the relationship between zeros and coefficient of a polynomial. You know what is zero? We have already discussed pk is equal to 0, then k is known as 0 of the polynomial. We also know what is coefficient. For linear polynomial, a and b are coefficient. For quadratic polynomial, a, b and c are coefficient. Similarly, for cubic polynomial, a, b, c, d are coefficient of cubic polynomial. So the relation between zeros and coefficient of the polynomial. You know, linear polynomial, the general formula is ax plus b. So it has maximum 1 0 and it is denoted by alpha. It is denoted by alpha, and you know it has two coefficients, a and b. So we have to find out one relationship between alpha and a and b, and that is known as what? Relationship between zeros and coefficient. One is zero and the other one is coefficient. Well, the general formula of cubic polynomial is ax square plus bx plus c. So it has maximum two zeros. The name of these zeros are alpha and beta. So we have to establish one relationship between alpha, beta and a, b, c, because alpha, beta are zeros and a, b, c are coefficient of quadratic polynomial. Well, the cubic polynomial is ax cube plus bx square plus cx plus d. So it has maximum three zeros. So these three zeros are denoted by alpha, beta and gamma. And the coefficient of this polynomial are a, b, c and d. So we have to establish a relationship between alpha, beta, gamma and a, b, c, d. So if it is linear polynomial, then the relationship is alpha is equal to minus b by a. So minus b, b means constant coefficient upon coefficient of x. If it is quadratic polynomial, the general formula is ax plus bx, ax square plus bx plus c. So the relationship is alpha plus beta. It has two zeros. So alpha plus beta again is equal to minus b by a. So b means coefficient of x upon a. A means coefficient of x square. And if you find the product of two zeros and it is denoted by alpha into beta, the formula is c by a. C means constant coefficient upon a. A means coefficient of x square. So you can also write this formula alpha plus beta is equal to minus coefficient of x upon coefficient of x square. We can also write alpha into beta is equal to constant coefficient upon coefficient of x square. Well, if it is cubic polynomial, means ax cube plus bx square plus cx plus d. There are three zeros, alpha, beta and gamma. So the relationship is alpha plus beta plus gamma is equal to minus b by a. Alpha into beta plus beta into gamma plus alpha into gamma is equal to c by a. And the third formula is alpha into beta into gamma is equal to minus d by a. You can also write this formula in words. That is alpha plus beta plus gamma is equal to minus b by a, means minus coefficient of x square upon coefficient of x cube. Alpha into beta plus beta into gamma plus alpha into gamma is equal to c by a. C means coefficient of x upon coefficient of x cube. The product of three zeros means alpha into beta into gamma is equal to minus d by a. So minus d means constant coefficient upon coefficient of x cube. So the very important article for exam point of view, and that is relationship between zeros and coefficient. Zeros are denoted by alpha, beta and gamma, while coefficients are denoted by a, b, c, d, and these are very important formula. The formula number 1, that is alpha is equal to minus b by a for linear polynomial. Formula number 2, alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a for a quadratic polynomial. And very important third formula is alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus alpha gamma is equal to c by a, and alpha into beta into gamma is equal to minus d by a, and this is for cubic polynomial. Now, point number 11 of this chapter, the last concept of this chapter, division algorithm of polynomials. We have already studied this concept in 9th standard. How to divide a one polynomial by another polynomial. So it is known as division algorithm of polynomials. If fx and gx are any two polynomials with gx is not equal to 0. The important condition, gx is not equal to 0, because you are dividing fx by gx. So denominator should not be 0. And that's why here you have to write one condition, and that is gx is not equal to 0. So if fx and gx are two polynomial with gx is not equal to 0, then we can say that, so we can find another two polynomials. The name of this polynomial is qx and rx, such that fx is equal to gx into qx plus rx, and this statement is known as division algorithm of polynomial, where fx is known as dividend, gx is known as divisor, qx is known as quotient, and rx is known as remainder polynomial. So you can also write this formula, division algorithm, in words, and that is dividend is equal to divisor into quotient plus remainder. For example, if you divide 8 by 3, so you can write 3 2 are 6 plus 2. So here 8 is known as fx. You are dividing 8 by 3 means 3 is known as gx. 2 is your quotient and 2 is your remainder. So you can write 8 is equal to 3 into 2 plus 2. Dividend is equal to divisor into quotient plus remainder. And this concept of mathematics is known as division algorithm of polynomial. So friends, in this chapter there are only 11 concepts. You know, to run any device, whether it is computer or a mobile, you need one operating system. Without operating system, you can't run a device. Even you can't run a computer or you can't run a mobile. In a mobile, you need Android. Why? To run a mobile. So the operating system is very, very important to run a machine. Similarly, you know, the concepts, mathematical concepts, they work as an operating system. If you understand this 11 concept properly, then you can solve any example of this chapter. So we have already focused on these 11 concepts of polynomials. These 11 concepts, they form a strong base of this chapter. So let us start exercise number 2.1. Find the number of zeros of the graph of the polynomial in each case. In this example, 6 graphs are given to you and you have to find out the number of zeros. I think it is easy because we have already studied this graph of linear polynomial, graph of quadratic polynomial, graph of cubic polynomial. So let me start one by one example. The first example, you can see this graph. The graph is intersecting y-axis, but it do not intersect x-axis at any point, and that's why it has no zero. And it is, linear polynomial. The graph of this example number 2 is a curve, and that's why it is cubic polynomial. And it intersects the x-axis at one point, and that's why it has 1 0. Here also in third example the graph is curved. So it is a cubic polynomial. It intersects x-axis at 1, 2 and 3 point, and that's why it has 3 zeros. In the graph of fourth one, it is a parabola. So you can identify it is a quadratic polynomial. It intersects the x-axis at 2 points, and that's why it has 2 zero. Here in fifth example, the graph is curved. It intersects x-axis at 1, 2, 3 and 4. So it has 4 zeros. So it is a polynomial with degree 4. In the example number 6, the graph is given to you. It is curved. So it is a cubic polynomial or a polynomial with degree n, and it intersects the x-axis at 1, 2 and 3 points, and that's why it has 3 zeros. So we have solved first example of exercise 2.1. This has no zero. This graph has 1 zero. Here it intersects at x-axis at 3 points, 3 zero. Here it intersects x-axis at 2.20. Here 4 zeros and here 3 zeros.